welcome everybody to another AskTOM Office Hours. This one is about JSON in the database, and of course we're here with Beda Hammerschmidt, who is our resident expert on JSON in the database, and he's going to be doing a short presentation on some cool stuff, and then we'll do some questions and answer at the end. If you have questions in the meantime, I'll put questions go here. You should see a chat thing on your screen that pops up there. Go ahead and throw questions in there. I'll try and answer what I can. If not, then I'll bring it up to Beda's attention and he can answer the hard stuff. But with that, Beda, if you'd like to take over.
Cool. Yeah, thanks for the introduction. So today I will give you the first presentation on SODA, the Simple Oracle Document Access API. So far what we did was mostly JSON and SQL. Now we're going to step a layer on top and see how we can see or work with the Oracle database as a document store. So for that, I figured instead of just giving you some information or slides, I thought it'd be more interesting if we build a small sample app. And I thought a setup or a scenario that everyone understands is a school where you have students and the students attend a course and the course is given by a teacher. So that's a very straightforward example that everyone gets. And how would you model this if you had to design this? Well, there are several methods. One is the ER diagram, pretty old, but you have these entities like student or course and teacher, and each of these entities has a few attributes. So for example, a student has a first name and a last name, and a course has a name. And then there are relationships between these entities. So for example, a student attends a course and a teacher teaches a course, and as the last thing you have these cardinalities. So the course is taught by one teacher. This is the one on top of teaches, but a teacher can give multiple courses. So this is the N on this direction. So this is really old stuff. And this translates pretty well into tables. So the attributes become columns and the relationships in some cases become an additional column. For example, the employee number points to the teacher. And if you have an N-to-M mapping, you need these mapping tables. Student ID points to student and code points to the course. And this way you can model the students that attend the course. This is old, decades old, but how would you translate this now to JSON? So this looks, at first look, this looks quite easy. So you start with an attribute. We picked out student here. And for each of these, or the entity students, and for each of these attributes, ID, first, last, grade, and so on, you just create a key value pair in your JSON data. So you have your student ID, 1, 2, 3, 4, 5, and you have values for the other attributes, first name, last name, and because it's JSON, you can easily add new fields or new attributes as you go. So you may find out later that you also need a value for when a student joined, or how often the student came too late. So you get schema flexibility pretty easily here. So this looks very simple till here, but we have these other two entities, teacher and course, and the relationships in between. So how would we model this in JSON? Well, this also looks easy initially, and I didn't have to come up with something myself. I picked out a JSON data model from another database, which is a NoSQL database, and they modeled this all in one JSON document. So because JSON is a tree, you have to now decide how you model the relationship in your tree hierarchy. So in this case, they've said there is a JSON for the person, and a person's role is either student or teacher. And then under this person, you have the course. So in this example, it's math, introduction to mathematics, and for the course, you have the start date and the end date. So here we have not kept these entities separate, but instead we mingled them together in one JSON hierarchy. And the implications of such data model are actually quite severe. So for example, here for every student that takes math, you have to repeat the start date and the end date. And if you want to update one of these values, let's say you want to have mathematics start a week early, you would have to go to every student, check if they attend this math course, and then update the same data over and over again. So now if your database is non-transactional, like the database in question here is, then you might have inconsistencies as well. And the next problem is, how do you store, for example, a course that does not have a teacher yet? So here, course is a dependent object of the person, which could be a student or a teacher. But let's say in the next year you want to have a new course, let's say physics, and you haven't found a teacher yet. Well, how do you represent this data? And there's also consequences about how can you query this data. For example, how do you find all the courses that a teacher gives, or how do you find all the students of a teacher or all the teachers of a student? And this is all quite problematic. And if you think about it, then you basically just got on a 50-year time travel into the past, because these are exactly the problems that predated the relational system. This is IBM IMS. So this is the database, the hierarchical database that was built in the 50s or in the 60s when they started the Apollo moon project, where they wanted to send a rocket to the moon. So this is an example of how not to do it. And now I want to show you how we can do this exact same thing with Oracle. So for this, I have prepared a virtual machine here. Are you guys still seeing this? Did I lose you?
Yes. Yes.
Oh, perfect. Okay.
I keep myself muted so not to distract the thing.
That's okay. Great. So now we're gonna basically build this from scratch, live here using Oracle. So I have a couple windows here. The one on the right bottom, which says comment.txt, you can ignore this. This is just for me to copy things over because I'm not that good at typing quickly. And we do have a SQL console here, and we have a command line, and we do have a web browser here. So the concept that I want to introduce to you is the concept of the document store, where you store your documents inside a collection. So a document in this case is a JSON instance, and collection is just a nicer name for table. But it's not a table that you have to create and where you have to think about the DDL and the columns and the data types and so on. Instead, you just tell us, create me a collection for teachers or one for students, and we maintain all the metadata and the DDL. So one easy way to create a collection is just to make a REST request. So this database here, it's a normal 18C Oracle database, but it has ORDS installed, the Oracle REST data service. And on top of ORDS, there is the SODA listener. So I can make REST calls to this listener, which translates this into SQL commands. And these SQL commands could be DDLs, like create a table or drop a table, or it could be queries. So in this example here, I make a put request. So this is an HTTP put request to some address, which is the local host. Then I have ORDS, Oracle REST Data Service. B is just my schema name. It's not Scott, it's just B. SODA is the service, simple Oracle document access, and so on. But at the last step, you see it's called student. So I want to create a collection which is called student. So ignore the output here. I hope it went through. So now I can do an HTTP GET in the web browser. Blaine, are you reading the chat in case someone is asking a question, or should I just go on here?
Yeah, I just answered the question. So the question was, why is there a latest in the URI down there?
Oh, got it. The latest is basically the version number. We're not doing actual versioning here, but this is a HTTP or a REST standard that Oracle has established for not only for database services, but for all kinds of services. And there are services where versioning is very important, so you can provide a version number there. But like most database services, only have latest here, but they have to comply with this Oracle REST standard.
And also, when you're using orgs like that, you can actually name the different pieces of that URI however you'd like. So if you'd like to make something that's non-compliant, I'll just say wrong, but if you'd like to make that be whatever you'd like, you have control over that as well.
I see. Yeah, I'm not an ORDS expert. I'm only an ORDS user here. So for me, ORDS is doing all the hard stuff like user authentication, figuring out if you have the grants to do things, and we're just piggybacking on this with the SODA service. Right, but now we did a GET request here in the Mozilla in the web browser, and we get a result back, which is basically items, colon, and then open, close square bracket. So we have an empty array, has more false means this has not more elements. This is basically an empty collection. So what happened is that we created a table under the cover that corresponds to this collection. So this will be storing the documents, the JSON data. So this table is auto-created. Every row is identified by an ID, which we also maintain. You can provide an ID value if you want, but the default is that we create the ID and can give it back to you. And we have the metadata when it was created, when it was modified. We also do have some version that we maintain. That is, if you want to have a cache on top, you can first look up in the cache if this version matches, and if not, you go back to the database. And finally, which is most important, is the actual JSON document. So now let's insert something into this student collection. It's now a post. It's an HTTP post. This is the data, -d is the data. So I'm inserting a JSON record. It starts here and ends there. And I'm basically inserting myself as a student. First name is Beda, last name is Hammerschmidt, and I have an array of courses where I say I'm attending a course called C1. And the rest is just boilerplate, that the content type is JSON, and where to go for the URL again, this org, so the latest. And if this succeeded, then we should see one record here. And we do, I just refreshed the web browser here, and we see there is one item. So the count is 1. And we have generated a long ID. And we have, this is the version, this is the E tag, but the payload itself is the value. And you see that the data I've just uploaded in this post has been inserted to the database. Similarly, if I would do a select, so this is the data is stored as a blob, but with $2 I can print it. JSON from students. Then you see the data is here in the table. So it's quite boring to only have one student. So let's do insert a few students. This is just a little script here, which does nothing more than making REST calls to the database. And now if I refresh my browser, I will see that there's a lot more. Or if I rerun this query here, I have to copy it. Then we should see that 30 students have now been inserted into the database. So this is quite easy for someone. So this is similar to MongoDB, for example. It's for application developers who don't want to bother a lot with learning or using SQL. They just want to make an HTTP request or call or put or get and see the database either accepting the data or providing the data. So yeah, because we stored in the Oracle database, we can use all the SQL aspects of it. So we don't have to make a choice. We've used a NoSQL API, which required us not to type any SQL, but we can still use SQL as you've seen here when we queried the data. Similarly, we could just also, for example, navigate into the data. So JSON document courses just will give us back the courses array, or if we I think document.first students. Yeah, then we just see the first names. So let's say we wanted to find a student based on some filter condition. We could either write this in full SQL here. I've shown you that with JSON exist and similar stuff in the past, but we can also just do an HTTP request again, where now we provide the query in JSON itself. So this is the query here. This is also very similar to MongoDB, where you put a piece of JSON that is matched against the data. And here we're asking for the ID being 2, and we post this to the same student's URL, but now the action is query, which means we want to run a query, and we get back this value here. So we call this query by example because you issue the query in some sort of a pattern that is matched against the data. So now this was the REST side of it. We can also write, or we also have the Soda API in Java. So I have this little Java program here where there's a little boilerplate where we create a client, and given the client, we create a Oracle database, and then an Oracle database has an admin feature where we can create a collection. I don't want to go into detail. This is just meant to be a teaser here. But basically here, I want to create a collection called teachers, and I want to add some data into it. I want to insert these 5 teachers here, Jasmine and Saul and so on. So this is just NoSQL in here as well. So let's run this. First, I'm going to show you that teachers does not exist. So I go here and look for the teachers collection, and it says collection teachers does not exist. Let's go to Java demo and have to provide the class path here. I already compiled it. Now I'm just executing it. You have to, if you want to use Soda for Java, you have to download a jar here, Aura, JSoda, something. And we're now running this. And now if I refresh, we should see that the teachers got inserted. So now we've done 2 collections here. Well, we created 2 collections, one through REST, one through Java. And
got a question while you're...
Yes.
The question is, the example action equals query was using an equality filter, ID equals S1. Can we use other types of filters too?
Yes, you can do greater and smaller. You can do regex like. You can also and or these conditions. So if you're familiar with how MongoDB does, then I would say there is a huge overlap in not only the semantics but also the syntax. But yes, you can express a lot of these queries. Interestingly, they're just translated to an equivalent JSON exists. So we don't have another query or filter engine for these QBEs. Instead, this Soda component of words just translates this into a normal SQL statement with a JSON exists predicate. So the database doesn't know that you're coming through Soda. It just sees and executes plain SQL statements. Okay, so now we also have our teachers table here, which looks exactly the same. And now we want to have the third entity, which was the courses. And here we don't create a collection. Let's just use, it's a normal create table statement. So for some reason we said, hey, we don't want this to be a collection. Let's just use a normal regular table for it. So I'm creating this table courses. Well, it's looking a bit similar. It also has the ID JSON document. Now it's a club, and I have this check constraint that I can only insert JSON into it, which I'm going to do now. So I insert these 5 courses. Just have to copy and paste it. So now I inserted math, computer science, and so on. So now we have all these tables created. Yes, and remember when I inserted the students, that they have this array of courses, and this was pointing to the ID of the course. So because I have a relational database, I can use references to another table. I can join these tables, and this is exactly what we're going to do. A lot of JSON stores are not very strong with joins, and this is why they are forced to put things together in one JSON hierarchy. So the reason, if you remember the slides where I said this is IMS from the 60s, everything is in one file. Well, the only reason it is this way is because that product cannot do any joins, but we can do joins, so it makes sense for us to store these entities separately. So now we can, let me just run this, that the printing works. Now we can run a normal query here where we do join the courses and the teachers, and we find out what the course name is that a teacher is giving. So we know that Jasmine is giving math and computer science, and we just did this by resolving the relationship between the courses table and the teacher table. So we look into the courses, look at the teacher, and resolve this with a teacher table, the ID, and then we just pick the name from the teacher and the name from the course. So this is quite simple, but again, this is something that would be quite hard with another product. Similarly, let's say we wanted to see this result. This is now a relational result here. Let's see, we wanted to see this as a JSON document. So we run the same query, but we put a JSON object on top. This way, we see it not as two different column values, but instead we see that one new JSON has been generated. So this is the JSON that was never inserted into the database. We have the teacher with a name, and then the course with a name, but then there was a course, or there was a reference using the ID. But here we can really generate new JSON that reflects the data that we want. Similarly, let's say we wanted to find all the courses for a student. We remember that a student can take multiple courses. This is why we have to use JSON table on the student and the course array. So we iterate over every course that a student participates in, and then we project out this course ID. We take this course ID and join it with the, we take the course ID, yes, we take the course ID and join it with the JSON table course ID. And this way we get the, where's the course name here first? Columnized. Oh, no, right. We are not interested in the course name. We're just interested in the student and in the, student and course. Again, sorry, I'm a bit confused here. So we want the student's first name, the student's last name, and the course name. So we select the courses, the students, we iterate over the student's course array, project out this course, and join it with a course ID. Sorry, this is the JSON table course ID, and this is the course ID from the course. So if we run this, we get all the courses that a student is taking. So Tim Raymond's is attending computer science, math, biology. And again, if we want to see this as JSON, we would just put this JSON object constructor on top. So this is the SQL constructor function, and we just put this on top, and we see the same result as JSON. So if another example here is, let's say, during the development of our little app, we find out that there are some courses which are problematic, meaning problematic is that nobody wants to attend them, or too many people want to attend them, they don't all fit in a room, or it doesn't make sense to give a course to only 3 people. So here we, for this kind of analytical query, we have to look at the courses, the student, as well as the teacher. And we can just use the aggregate functions to count the number of students. So we count the student ID becomes the number of students, and I'm not going into all the details. I think this is wasting a bit of time, but I want to show you that you can still use normal SQL for all kind of analytics, and we find out that there are too many people in math and not enough people in physics. And let's say we wanted to create a view on this one. Then I just have the same query with view. But now in the view, I also use these JSON functions to generate the data. And now I can basically see the exact same results as one JSON array of these problematic courses. So there's one is the object for math, the other one is the object for physics, and I get all the data inside. So last thing is,
I have a question right there on that topic. What join methods are used when we join tables by JSON attributes? I mean, when there are millions of records in each table, how do we guarantee performance here?
So it's typically a JSON table join that's happening. So we go to the you will see a nested loop join here. But this is just because it's a lateral join between the base table and the JSON table. So a lot of like the optimizer often materializes these things to be more performant. So it will run the JSON table over the input to it expands out or it flattens these arrays, and that will be joined with the other table. And the optimizer chooses whether this intermediate flattened values, whether they are materialized or not. Does this answer the question? Good. So let's say there is something we forgot in our application. Let's say we want to find out how much, so we already have rooms where physics or math takes place, but let's say a room has a capacity. We forgot that. So we create a new table here, which is called room capacity. And in our rooms, so the table is purely relational now. There is no JSON in this table. I want to basically show you that you can work with JSON as well as relational data in a hybrid manner. So we say there is a room Gauss, can take 20 people, create 25. So this is a very simple relational table. Again, with the simple ag function, I can get you all that data in one JSON object. So you know Gauss has 20. So it's very easy, basically, if some mid-tier developer or front-end developer says, hey, I want to only deal with JSON data. I want to send you JSON data, and I want to receive JSON data. That does not necessarily mean that you have to store this JSON data. You can see here that it's very easy to take a relational table and turn it into JSON, hand it to someone who, for some reason, doesn't want to interact with SQL-ish or with tables. So now we want to do an update here. So we do have our courses here, but what's missing now is in our courses, how many students are attending it. So we know, for example, biology takes place in Darwin, but we don't know how many people are taking or how many people are participating in biology. So I just run an update here. And the update works using JSON merge patch. Hey, 1 second, my kids are yelling. I'll be back.
All right, so while he's taking care of that, I'll just kind of inject in here that one of the really great features of all of this is this gives you the ability to use all of the JSON functionality that we're looking at with all of the advanced Oracle database query functionality. You can mix and match, if you're into spatial, graph, analytics, all of that, you can mix all of the Oracle, the real powerful Oracle database features with the JSON functionality and get the best of both worlds.
Yes, exactly. So I'm back. Apologies. My kids were just starting a yelling contest and I wanted to stop it as early as possible. So now we run this, this update here. We just ran this update where we use this JSON merge patch operator to calculate the count in SQL, but then injected into our JSON here. So we merged two JSON documents. One had the student count, whose value was just a count from a relational query. We merged this with the existing data with the effect that the student count got injected into this JSON data. So now we know that the student count for biology is 9, for example. So the last thing is...
Got one question right there, Beda.
Yeah.
What function is JSON underscore merge path? It's not documented in 12.2 nor in 18C.
It's working in 18C. I'm not sure why it's not documented. I would have to look this up, but you can play with it.
And there was a longer one from Sven. So I'm going to read a little bit here. It says, I believe because the CLOB column has an is JSON check constraint, there exists a JSON index. The optimizer should be able to use that index depending on the query, but the execution plans would be interesting. What I doubt is whether the same quality of statistical information is available as we are used to for normal indexes.
So the isJSON check constraint is really only an isJSON check constraint. So you can add additional indexes. One is the JSON search index. Maybe Sven was thinking of this, but that would have to be explicitly created on this column. And the other options you have is just to use normal B-tree indexes, where you specify what field values to extract, and they go into a normal B-tree index as a normal functional index. Yeah, maybe to clarify, I'm not advertising here that people should stop relational development and do it this way only. That is absolutely not the point I want to get across. I'm just trying to show that JSON and relational can perfectly coexist, and there are reasons why people choose JSON, and one of the strong reasons for JSON is schema flexibility, where you may start with a schema when you start your application, but as you go you may get more requests, have to store additional data, and some people feel it's just very cumbersome and expensive to keep modifying your relational table.
All right, and then a couple more from the chat. It says the quality of statistics is quite interesting in JSON documents since they are not cooked preliminarily. I think I said that word right. And we don't know in advance the structure of the data tables. Then how is it materialized? I mean, this non-structural data. I think those two go together. Comments?
Okay, I just opened the chat here. Oh no, this is not the one we're using.
In the middle of those two, there's a request for a live SQL demo as well.
Yeah, statistics, I don't think that if you do not have an index, I think it's primarily rule-based. So if you have a, well, no, I have to take this back. There are some statistics when the optimizer executes this, whether it chooses to materialize or not. So there is some dynamic sampling happening. But normally, if you have a JSON table over large inputs, the materialization of the intermediate results is happening. So I'm not sure if you can derive all that from the plan, if you print the, or if you set auto trace on explain, if you see all these things that are happening. But again, if you run a JSON table statement quite often, there's nothing stopping you from not materializing. Again, you have the full ecosystem of the Oracle database, and all the relational goodies or optimizations that are possible also apply for JSON. So you could just create, for example, not only an index, but a materialized view, or you move data in memory. The other question then, how is it materialized? Oh, JSON merge pad. Yeah, live SQL for merge pad. I'll try that. So Dennis asked then how it is materialized. I mean this non-structural data. Don't understand it. Okay. Okay, so apparently I asked the question. So we're coming to an end. What I also want to show you, so this presentation is also given to people who are not that interested anymore in relational databases, who are basically totally flying the NoSQL world. And now I've basically created with the student count, I've created an example where you need to do a change transactionally. So if some student is taking a new course, then you have to do things. You have to add the course ID to this array, and you have to increment the student count by 1. So let's say in our application development, we want to now have a front end where a student can just pick a course and add herself to the course. So for this, I've done this in a PL/SQL procedure. It's a relational construct here, which plays very well with JSON. And it's called add student to course. And we just give it a student ID and a course ID, and we get some output. So I quickly go over this. We have to do some checking of whether the student count exists. So we just select whether there is a course or a student with this ID. So then there's student or course not found would be returned as an error status. Then we lock these two rows, the course and the student, and we have to check whether the student has already admitted herself to this course. So this is another error. The student is already in the course. Then we have to see if there is still place in this course or in the room. We select the capacity, or we select out the student count here. This is a JSON value where we retrieve the student count out of the JSON, and we select the capacity for this room, which means we also extract the room here. This is the third error. If the room capacity is smaller than the student count, then the course is full. And last but not least, we parse the student object with this JSON object constructor here. So this generates a JSON object T instance given the text input. We navigate to the array. So we do a student object get array courses. We append the course to this array. We reserialize it using this toBlob function, and we run the update. And similarly, we parse the course, meaning that the course is stored as a JSON text. We turn it into a JSON object T, and we increment the student counter. So it's student count plus 1. We turn it into a CLOB because we stored the courses as CLOB, and then we do an update here. And because it's PL/SQL, these two updates either work both together or not at all, so we have a transactional. And I've already created this function or this procedure, and it's also REST enabled. So now again, I can make a REST call here I'm just pasting it here. So this is the address. This is now ORDS, this is not SODA, but you can see that you can also invoke a procedure using REST. This is our school module, add student to course. This is the payload, student ID number S9 should be added to C2. And if we run this, we should see an error because the student is already in course, and this is right because C2 is already in this array of student 9. So let's add this person, the student, to another course. Let's add him to course number 3. And this was a success. So now if we rerun this query here, we should see that C3 has been added exactly. And just an example, if the room is full, see if this works. This is just another condition. Yes, course is full is also being returned. So this completes this little demo. So what I've shown you here is that with the Oracle database, with the Oracle database and SODA, you get the best of two worlds. You can interact with the database like with a document store or a NoSQL store. You can make REST calls. You can use Java to access it. We're also working on PL/SQL drivers. We're also working on Node.js. So that is a road where you're going to see a lot of things happening in the future. But the choice whether you go NoSQL or SQL is not really a choice you have to make. With Oracle, you can basically say, NoSQL is just a way of interacting with the database, and it does not stop me or block me from using all the very mature features that SQL has and that a lot of people do understand. If you want to learn more, just Google Oracle as a document store or SODA. There is a website for this where you can get the pointers to the Java jar files to download and some other presentations, and we may put this video up there as well.
We've got a question on how is security managed by ORDS and SODA. Is it possible to filter out specific rows by user and not allowing the user to see all rows? Let me address the ORDS part of that really quick. If you think of ORDS as a low-code type tool that you can put on the database to create REST APIs, those REST APIs invoke either SQL and or PL/SQL functions in the database. So ORDS will handle like your authentication and your authorization to make sure that you're authorized to make the connection. And then once ORDS is mapped, once your REST API is mapped to a SQL or PL/SQL function, then you have all of the rest of the Oracle features, the database features, to control whatever data you want in or out using SQL and PL/SQL. I'll let you address the SODA part of that.
Yeah, SODA does not add anything to authentication or authorization. This totally relies on ORDS. So, and I'm also not an expert on the ORDS things there. For me, it's just taking care of it. So,
if you have detailed, specific ORDS questions, if you're on Twitter, you can follow that Jeff Smith, and you can tell him I said he knows everything. So he can.
So there's another part of the question where it says to filter out specific rows by user and not allowing the user to see all rows. That question, I think, has little to do with JSON in this example. There may be Oracle features like, I don't know, row level security or so, VPDs that could also be probably enabled here, I would guess.
You look up fine-grained access control.
Yeah.
It could help you with that.
Right. Yeah.
And then the next one down, it says, and right now you mentioned explicit creation of materialized views. So mainly the question is, should we think
right now you would, like with all the releases that are available right now, you have to manually create these materialized views. I can't say anything more than that. Yes, it's something where you may see some automation in the future.
Another question saying, so the schema or ORDS was enabled to allow access to any procedure. I can talk about that. Yeah. So the way you start out with ORDS, once you've got it installed, you can use SQL Developer is a great tool for this. It has some built-in wizards where you can just go into the connection, right-click on the connection, and enable the schema. And then at that point, that just lets ORDS, it makes ORDS aware of the schema. And then you go in and you create specific REST services, and you map those services to specific SQL or PL/SQL calls. And
it is not that you can call any procedure. You have to explicitly, or at least that's how I understood it. So I have this thing here. This is ORDS define module, where you define a module, and the module has these procedures. I mean, you can explain this a lot better than I, Blaine, but I just want to show it because I have it here.
So there is a way that you can go in and REST enable a schema. I mean, if you're brave and or don't care about the security so much, you can go in and REST enable a schema and use a wizard to say enable everything. I didn't do that.
I did not do that.
Yeah. So it's possible, but I wouldn't recommend. I believe in fine pointing my REST API to go exactly where I want it to.
Right, yeah. So the way it works here is I defined this module, I called it school module, and I said there is a procedure called add student to course. It's listening on this post style HTTP access, and these are the, this is the signature basically. So yeah, it's a bit of typing here. It's looking long, and it took me a while to write this down and get it working, but I think this is a one-time learning experience. Once you know how it's done, everything else is just repetitive.
I'm putting a link into the chat that will take you to thatjeffsmith.com, and it's an Oracle REST Data Services blog post that I link to, and this is a great place to get started with ORDs. Jeff has a lot of really good material out there on working with ORDs several different ways. You can do it through SQL, like what Beda has, or you can use the wizards in SQL Developer.
So very often, I mean, just to come back to the whole motivation of it, maybe I didn't make this really clear, but very often developers want just the NoSQL API because they perceive it as being easier, and they may not really care what the back end, how the data is being stored. So this is something we hear quite often, that some DBA of a corporation comes to us and says, hey, the developers want X, Y, Z because they think they're getting more productivity out of it. So then we show them this soda layer, and very often they say, actually, yeah, well, that's exactly what we wanted. This works very well. Give us more drivers. REST is great, Java is great, but give us this. We're working on that. And at the end, it's much easier for the DBA who knows how to manage the data and how to do with updates or security issues, how to optimize things. So it's kind of a win-win situation, which I think we're able to create here.
And there's a little bit of a discussion going on in chat about best practices for ORDs. ORDs is related but slightly off topic. If you would like, we can probably set something up where we could have a separate discussion about that. But I would recommend starting out on Jeff Smith's blog posts and digging in there. And I'll poke Jeff and see if we can get him to maybe do an office hours on ORDs, see what we can pull out there. But he has a lot of awesome material out there in both his blog and YouTube.
Okay.
We have a request. Could you please scroll back to the function definition where you added the student to the course?
Yes. Would be this one here, right? You could even, yeah. So this is showing the built-in types that we added, I think, in 12.2, this JSON object T, JSON array T, which are in memory. So this allows you to interact with JSON inside PL SQL, so you can parse. Let's go down here. For example, here, so student JSON is a text JSON record, and this is a constructor that turns this into the in-memory representation. And then on this, you can do puts and gets, or check if it has a field or what data type it is. So this is some way of programmatically interacting with JSON. It's a bit longer than JavaScript. Obviously, in JavaScript, you could just say student object dot a dot b. Here you would say get array, or just get. If you do a get could be anything. It could be a scalar, it could be an object, it could be an array. This is where we have this JSON element T, which is a super type of object and array and scalar, and then you can ask it, what are you? But here I assume that courses is an array. I have this implicit knowledge, so I could just use get array to get, or to extract this information from the student and turn it into a course array, and course array is of array type.
So a follow-up from that question, it says, so the objects are only pointers to an internal representation of the JSON?
That's correct, yes. So the workflow is such that you parse a JSON into this in-memory representation, then you can modify it or check it or do whatever you want. And if you modify it, you can reserialize it to text using a toVarchar or toBlob or toClob function like here. So this is then again the updated student JSON. Student JSON was a blob here.
And then we have a question that says, what are the advantages of using SODA over REST? Is it just another interface, which is familiar for Java developers?
The question is compared to what? SODA over REST versus SODA over Java, or? So I missed, what are the error using SODA over REST?
I think the question is asking using SODA instead of REST.
Well, SODA is a concept of an API. So SODA means that you see your data as documents inside a collection, and you query them using QBE's query by example. So that's just, at this point, this is just the concept. And then you can say, well, this concept can have an implementation in REST or in Java or in Node.js or in .NET. So this is then the actual implementation of the concept. So we have SODA for REST demoed here and SODA for Java. It's kind of the same concept, just in a different language.
So you wouldn't use SODA instead of REST. You would use SODA. You could use SODA with REST.
Exactly. Yes. REST is more like a infrastructure thing. It's an HTTP call, but it doesn't really mean what concepts are transmitted over the wire. SODA is more really the way you interact. It's what kind of REST messages you send. Yes. And obviously, because REST is stateless, you couldn't do anything really transactional. The workaround I took here is to say, well, I have some stored procedure which I exposed through REST, but all the transactional stuff is happening inside this procedure. If I had changed the course and the student through REST calls themselves, then there is no commit or rollback. Then I would have to code all this logic for this to happen transactionally somewhere in my mid-tier. Whereas in Java, you could just make these changes because the SODA for Java driver relies on a normal JDBC connection, and then you can set this JDBC connection not to auto-commit, but to be actual transactional. Then you make all your changes in your connection, and then you commit it at the end, or you roll it back. So this way you wouldn't have to do it using a stored procedure in Java necessarily. It might still be a good idea to do it, to say this kind of logic belongs to the database. That really is a personal preference at this point. With REST, it's certainly needed. But with Java, you could say, well, I modify all these objects in my transaction, then I commit it myself.
All right, so while there's a pause in the questions, I'm going to post a link back up. This is the link back to this AskTOM Office Hours session. We'll be doing more of these in the future, so there's a subscribe button on that page if you'd like to get email notifications when the next session is going to be scheduled. That's a good reason to hit the subscribe. We don't send out spam, so it's safe to put your email on there. If you're not comfortable subscribing, just check back on that link every now and then to see when the next one is, or follow Beda on Twitter, or follow me on Twitter, or I should say. And then you'll get notifications for the next one. Okay, another question here.
Apex 81, yes, SODA ships with ORT. If you have, I think starting with 12.2, if you installed ORT, I believe that SODA is already shipping as part of it, but you have to SODA enable your schema. So there's nothing turned on by default for various reasons, security being one of them. You don't want everything to be REST accessible by default. So you have to, I think I do have it up here. ORT enabled schema. Yeah, you have to run this. No, this is just to turn on some privileged mesh. Yeah, I don't know it now out of my head, but you have to do something with SODA to enable it. There's another question I must ask. So where is this thin border when we should stop using relational schemas and go for JSON document store? I mean, we can store nulls in a relational store. So when should I stop and refer all this JSON? Well, I don't think, I mean, I don't want to be a cheerleader for JSON here and say it's solving world hunger and all that. Honestly, I'm a database back-end developer. I don't do a lot of application development, so I'm not kind of a guy who built 1,000 applications. So it's a lot of it, I think right now, a lot of people are still learning. It boils down to a lot of personal preference. A lot of people say that because schema flexibility matters a lot, we want to use JSON. They've spoken to companies who said we allow other partners to augment our data and we don't know what fields they want to use, so they also use JSON for that. Generally, if you think along these lines, that you say, I really don't know exactly how my application looks like, then you may want to introduce JSON, at least to some degree, as flex field, for example. There's a lot of hybrid stuff going on where the core fields are relational, but then there is some sort of flex field column where you store JSON data. We see that a lot, but we also see people jumping straight to all JSON, but it's hard to really tell why they did that. It's not that this use case is really good for JSON and it's not good for relational. This is very hard to tell. I think it's really the people making this decision, how they feel about it. And I'm not religious about it. I mean, I like if people use JSON because I coded it, but if people say they prefer only to have a subset in JSON or nothing in JSON, I'm fine with that too. So
I'd add on to that too. Of course, the very precise answer of it depends. What I like to do when I'm looking at an application is evaluate each each data set. So not the entire set of the data in the database, but when I'm looking at something, a particular thing like is students going to be represented better by a relational table, or would students be better represented as a JSON document, and make it develop an application, make it a case-by-case call on the data itself. Whichever works better, use it. And that's the great thing about JSON in the database is you can use both. You don't have to do all or none. Start out small and work your way into what works best.
Right. And very often, I mean, the people I typically speak with are more on the Oracle database side, and for a lot of them, it's an external requirement to either accept JSON or generate JSON. And very often the requirement is that, hey, we want to do everything in JSON now, so let's not use Oracle, let's use product ABC instead. And that often fires back if people say, hey, now we can store and find stuff very quickly, but oh my God, reporting doesn't work at all. Now we have to offload the data out of this new fancy store and load it into Oracle just to do like a little report, and now the data is 12 hours old. I mean, these are the horror stories I heard quite often, so that people ask, hey, we want to have all of what these people ask inside Oracle. So we can give whoever asks for JSON, we can give them JSON, but we are not forced to abandon a lot of just decade-old relational things. I mean, a view, a join, a transaction, come on. This is like, you learn this in the first week when you study databases at a university, but it's still something that a lot of application developers kind of question whether that's really needed. They say, oh, I have this kind of query. Yes, the database can answer it. I'm just writing like a little Java program or JavaScript program that does the join then in the mid-tier. And oh my God, it's not performing very well. So
there's a question on how does SOTA compare to Swagger/OpenAPI?
I think it's, again, different concept. I don't know if Swagger, I mean, I have to admit, I'm not that familiar with Swagger. It rings a bell, not very loud though. I don't think, does Swagger have the concept of collection and documents inside a collection and expressing queries as JSON? I think Swagger is, again, some, let me just quickly open it, see if there's, Swagger is a description of an API. Is that correct? Something like Whistles were in XML. I don't know.
Yeah, I'm also not very familiar with Swagger, so I can't really help answering that question.
Well, maybe the person can unmute himself or herself and just ask. Maybe if that helps.
Sven, do you have a microphone? Would you like me to? I'll try and.
Oh, he says he doesn't know much about Swagger.
Oh, okay. Yeah, sorry, I can look into it.
I mean, I think I knew more about it and then I forgot about it. That's benefit of getting older, or not a benefit, but a consequence. So I think it's some sort of description of a REST API. So SOTA does not describe anything. SOTA just means you have a way of interacting with a collection, which under the cover is a table. But from a user's point of view, you may just say it's a bag of things. And typically these things are JSON documents. We also have a mixed collection. For example, if you want to store binaries like images, then you can say I have a binary collection, but obviously then it's not that powerful to query it. You can basically just get back some image by its ID, but you can't look inside the image because we don't really know what you stored there. But it's really a very, very simple idea. It just means, well, I have a bag of things, and that bag is called collection, and inside I have documents, and I can find these documents with some sort of a query language, and for all of this, I don't need to understand or write any SQL. That said, if you have complex queries, I personally believe that SQL is a lot more readable than these QBEs, that because they have to be JSON, they have to kind of nest things in objects and sub-objects. Just look at, I think what we can do next time, it seems there is quite some interest in it, where we can dig into some detail. So this was really just meant as a teaser where we had a concrete application and I showed you how this can be built. We can do some sort of overview over or a feature expansion of SOTA where I can show you, well, this is really how you do a complex query. This is how you create an index and similar things. Seems this could be a good topic for one of the next AskTOM sessions.
One thing you can do in the AskTOM Office Hours page is you can submit questions ahead of time.
Yeah.
So maybe what we do is everybody that has these questions, submit them in, and then we can formulate a session that covers the most requested topics.
Yeah.
I think we missed a question back up there. It said, so is it a good idea to mix approaches? I mean, to use relational approach for the structure you're quite sure about, and to leverage the JSON approach for the rest of attributes?
Yes, this is I call this flex fields. In the past, when you knew that you needed additional fields, but you didn't know which fields they are, you had like, I don't know, number 1 to number 10, varchar 1 to varchar 20, and then if you had to store the shoe size of an employee, you pick number 4 or something like this. Yeah, you could, instead of that, you could just say I have one additional column which is which stores JSON data, and I use that to gain some schema flexibility. Exactly, this is done quite often. So this is one of the most typical use case. Besides people going all in JSON, where they store everything in JSON.